Have you ever wondered how NASA tested nuclear rocket engines in the 1960s? Today, we're delving into one of the pivotal moments of space exploration, the inception of NERVA. This innovative beast, formerly known as the Nuclear Engine for Rocket Vehicle Application, was a nuclear thermal rocket engine developed by NASA in collaboration with the Atomic Energy Commission, or AEC, and other partners. Its main goal? To harness the astounding energy released by nuclear reactions to propel spacecraft. This was a game changer, as it offered greater efficiency and thrust compared to traditional chemical rockets. But to make this vision a reality, a series of tests were needed. These were known as the Green Run tests, a crucial part of the NERVA development program. These tests were not just about pushing boundaries, but also about ensuring the future of space exploration. The Green Run tests were a critical part of this development. So what were the origins and objectives of the Green Run tests? Let's dive in. The Green Run tests were born out of the NERVA development program, a pioneering venture by NASA that sought to push the boundaries of space propulsion technology. The primary mission was clear: to put the NERVA engine through its paces, testing its performance, endurance, and safety under conditions that mirrored real operational scenarios. The tests were designed to answer key questions. Could the engine withstand the rigors of space travel? Could it deliver the thrust needed to propel spacecraft into the vast expanses of the cosmos? And perhaps most importantly, could it do all this while ensuring the safety of those on board and the integrity of the mission? These were not just experiments, they were trials by fire, taking place under the watchful eyes of the world's top scientists at the Nuclear Rocket Development Station in Nevada. These tests took place at the Nuclear Rocket Development Station in Nevada. Before the Green Run could commence, extensive preparations were necessary. Like meticulous clockmakers, the engineers at the Nuclear Rocket Development Station dove into an intricate dance of checks and balances. The test facility underwent rigorous inspections, every nook and cranny scrutinized for potential hazards. This was not simply a matter of ticking boxes. The stakes were high, and an overlooked anomaly could spell disaster. In tandem with the facility inspections, a symphony of calibrations was being performed on the multitude of instruments tasked with monitoring the NERVA engine. Each instrument's accuracy was paramount in acquiring reliable data, the lifeblood of the Green Run tests. Beyond the immediate confines of the test facility, the surrounding area was not forgotten. Measures were taken to secure it, ensuring that neither curious onlookers nor local wildlife would inadvertently find themselves too close to the action. These preparations ensured the highest levels of safety and accuracy, setting the stage for the groundbreaking Green Run tests. With preparations complete, it was time for the test setup. The heart of this operation was the NERVA engine, a marvel of engineering and a testament to human ingenuity. It was carefully mounted on a specially designed test stand, a colossal structure built to withstand the immense forces that would soon be unleashed. But the setup was more than just the engine and the test stand. A complex array of monitoring and control systems was put into place. These systems were designed to capture every minute detail of the test, from the engine's performance to the slightest environmental changes. The control systems were the nerve center of the operation, allowing the team to maintain a firm grip on the proceedings. They were equipped to adjust parameters on the fly, react to unexpected developments, and if needed, abort the test to ensure safety. Highly trained engineers and technicians were on hand to ensure all protocols were followed. Their expertise was vital in orchestrating this grand symphony of science and engineering. The countdown for the Green Run was a moment of intense anticipation. As the seconds ticked away, the air was thick with a mix of excitement and tension. The meticulously calibrated systems of the NERVA engine were put through a final sequence of checks, each one signaling a step closer to ignition. The process was a symphony of precision and coordination, with each system's status being verified in succession. From the fuel flow systems to the intricate network of sensors, every component was confirmed ready for action. This was the culmination of countless hours of preparation, a collective holding of breath before the plunge. And then, at the designated moment, the NERVA engine roared to life. The ignition was more than just a burst of nuclear energy. It marked the start of an audacious experiment, a bold stride into the uncharted territories of space propulsion. With the ignition, the Green Run tests officially began. As the tests progressed, data collection was a vital part. The Green Run tests were not just about igniting a nuclear engine, but also about understanding it. A multitude of sensors and instruments were put to work, like diligent scribes, recording every minute detail of the NERVA engine as it roared to life. These devices monitored an array of parameters, capturing the engine's thrust, the internal and external temperature, the pressure within the combustion chamber, and the radiation levels. Each piece of data, each number, and each reading was like a piece of a puzzle, providing insight into the behavior and performance of the engine under full power. As the data streamed in, it painted a picture of an engine being pushed to its limits, a testament to the marvels of human engineering. This data was critical for evaluating the engine's performance and safety. It was the language in which the NERVA engine told its story. Engineers were kept busy with real-time monitoring and analysis. Imagine a symphony of data streaming in, each note representing a different parameter, from thrust and temperature to pressure and radiation levels. With each passing second, the NERVA engine revealed its secrets, like a cosmic puzzle coming together in the hands of these diligent engineers. This wasn't just a passive observation, though. The engineers were on constant vigil, scrutinizing every piece of data, every spike, every dip. If an anomaly appeared, if the data deviated from what was expected, it was promptly investigated. It was like being detectives on the trail of a cosmic mystery, with the integrity of the test at stake. With their keen eyes and sharp minds, they ensured that the Green Run tests were not just a demonstration of nuclear propulsion, but a masterclass in meticulous monitoring and analysis. This rigorous analysis ensured the integrity of the test. Safety was a paramount concern during the Green Run. As we ventured into the unknown world of nuclear propulsion, the well-being of the crew and the surrounding environment was always at the forefront. To ensure this, strict safety protocols were put in place. Contingency plans were drafted to address any emergencies that could arise. These plans were comprehensive, covering everything from minor malfunctions to major system failures. They were designed to respond swiftly and effectively, minimizing potential damage and risk. In addition to these contingency plans, strict protocols were also enforced for personnel evacuation. In case of an alarm, every individual knew exactly where to go, what to do, and how to protect themselves. This level of preparedness prevented panic and confusion, ensuring a smooth evacuation when required. These safety measures were not just about preventing accidents. They were about creating a culture of safety. By instilling these practices, we could ensure the well-being of all involved. These safety measures ensured the well-being of all involved. The Green Run wasn't just a single test, it was a series, each one designed to put the NERVA engine through its paces, pushing the boundaries of nuclear propulsion technology. Imagine a symphony, composed of movements, each with its own tempo and intensity. That was the Green Run. A symphony of tests, each distinct yet integral to the whole. Some tests were short, explosive bursts of full power, like the grand crescendo in a musical piece. These tests pushed the engine to its maximum capacity, testing its limits and resilience. Then there were others that simulated prolonged operation, akin to the gentle and steady rhythm of a symphony's adagio movement. These tests were designed to assess the engine's long-term performance, endurance, and reliability. Each test, regardless of its duration or intensity, contributed valuable data to the overall picture. These variations allowed for a comprehensive assessment of the engine's performance, painting a detailed portrait of its capabilities and potential. After each test, a comprehensive evaluation was necessary. This evaluation was a meticulous process, designed to dissect each aspect of the NERVA engine's performance. The first step was data analysis. Engineers pored over the wealth of information collected, from thrust and temperature to pressure and radiation levels. Each data point provided valuable insights into the engine's performance under varying conditions. Next came the physical inspection of the engine components. This was a hands-on operation, with technicians examining each part for signs of wear, damage, or unexpected behavior. Any anomalies found were thoroughly investigated, contributing to a deeper understanding of the engine's overall endurance. Lastly, post-test simulations were conducted. Using the data collected, engineers recreated the tests in a virtual environment. This allowed them to explore different scenarios, probe potential issues, and test hypotheses in a safe and controlled way. This evaluation helped identify areas for improvement. By constantly learning and iterating, NASA was able to refine the NERVA engine, inching closer to their goal of nuclear-powered space exploration. Despite the cancellation of the NERVA program, the Green Run tests left a lasting impact. They were far more than a series of ambitious experiments. They were a bold leap into the unknown, a testament to human ingenuity and the relentless pursuit of knowledge. The Green Run tests were the first to fully harness the power of nuclear reactions for rocket propulsion, setting an unprecedented benchmark in space exploration. The echoes of their influence can still be heard today. They've shaped our understanding of nuclear propulsion, illuminating its potential and the challenges it presents. Even though the NERVA program folded in the 1970s due to budget constraints and shifting priorities, the lessons learned from the Green Run tests were not forgotten. They've been carried forward, informing and inspiring a new generation of scientists and engineers. Today, as we stand on the cusp of a new era in space exploration, we look back at the Green Run tests with gratitude. Their knowledge continues to inform current efforts to develop advanced propulsion systems for future space missions.